Hello and welcome everyone for today's video presentation prepared by Group 2, in which we will be discussing about Jefferson's method. Thomas Jefferson proposed an alternative system for apportionment. Instead of relying on the standard divisor, his method uses a modified divisor and recalculates quotas until they equal the total number of seats. Positive surplus, smaller divisor is tried. Negative surplus, larger divisor is tried. This iterative process continues until the quotas align correctly. Jefferson's method was applied in the U.S. Congress from 1791 to 1842, after which it was replaced by Webster's method.
So before we proceed to the steps, problems, and solution, let's explain what is Jefferson's method. Jefferson's method, also called the D'Hondt method, is a mathematical method used to allocate seats in a proportional representation system. It was first proposed by Thomas Jefferson in 1792 and later independently developed by Victor D'Hondt in 1878. This method distributes a fixed number of seats among groups or parties based on their population or total votes. The process works by dividing each group's population or votes by a series of divisors such as 1, 2, 3, 4, and so on. The highest resulting quotients are used to assign seats until all seats are distributed. In Jefferson's method, quotas are rounded down to obtain whole numbers called lower quotas. If the total number of seats does not match the required house size, the divisor is adjusted and the calculations are repeated. Because the method always rounds down, it usually favors groups or parties with larger population.
So before anything, let's define some important terms. First is standard quota. It is the population of a region divided by a standard divisor. Second is lower quota. It is a standard quota that rounded down to a nearest whole number. So for example, if the quota is 5.8, the lower quota becomes 5. So next is third, modified divisor. This is a number smaller than the standard divisor. It is found through trial and error and is used when the initial lower quota do not add up to the total number of seats. Next is fourth, modified quota. It is calculated by dividing the population of a region by the modified divisor. Next is fifth, modified lower quota. It is a modified quota rounded out to the nearest whole number. And lastly, apportionment. It is the final number of seats assigned to each state or region.
So let's proceed to the steps and procedures. The Jefferson's method is used to fairly distribute representatives among states based on their population. First, we find the standard divisor. This is done by dividing the total population of all the states by the total number of representatives. The result tells us the average number of people that one representative should represent. Second, we compute the quota for each state. To do this, we divide the population of each state by the standard divisor. The answer shows the estimated number of representatives that a state should have, and this usually includes decimals. Third, we determine the lower quotas by removing the decimal part of each quota and keeping only the whole numbers. Then, we add all these numbers together. The total will usually be less than or equal to the required number of representatives. Finally, if the total is still less than the number of representatives needed, we adjust the divisor by making it smaller and then repeat the calculations. This process continues until the total number of assigned representatives exactly matches the required number. The divisor used in the final computation is called the modified or adjusted divisor.
Now that we understand the theory, let's look at the practical sample problem. Imagine we're in the state of Delaware, which is made up of 3 counties: Kent, Newcastle, and Sussex. Now, based on the latest consensus, our total population across the state is 897,934 people. Our task is to distribute or apportion exactly 41 seats in the local legislature among these 3 counties. To do this fairly, we are going to use the Jefferson's method. We'll follow a 4-step process, which contains: first, we'll find the standard divisor to see how many people each seat represents. Second is then we'll calculate the standard quota for each individual county. Third is we'll find the lower quota. This is our initial floor for the seat count. And fourth is finally, if those numbers don't add up to 41 seats, we will hunt for a modified divisor to balance the scale. Now let's look at the data table. Kent has over 162,000 people. Newcastle is our largest with over 538,000 people, and Sussex has about 197,000 people. Keep these numbers in mind as we head into the next calculations.
Now let's move on to solutions. Step 1. Find the standard divisor. The total population is 897,934 people, and the total seats is 41. We calculate the standard divisor by dividing 897,934 divided by 41 is equals to 21,900.2. This means each seat represents 21,900.82 people. Step 2. Calculate the standard quota. Now, we divide each state's population by the standard divisor, which is 21,900.82. Kent has 162,310 divided by 21,900.82 is equals to 7.411. Newcastle 538,479 divided by 21,900.82 is equals to 24.587. Sussex has 197,145 divided by 21,900.82 is equals to 9.2. Step 3. Find the lower quota. We take the whole number part of each standard quota. For example, Kent 7.411 is equals to 7. Newcastle 24.587 is equals to 24. Sussex has 9.002 is equals to 9. And now we add them is 21,538.83 because 7 plus 24 plus 9 is equals to 40. We need 41 seats, so the total is too small. We need to lower the divisor. Now step 4. Adjust the divisor. Lower the divisor until the sum of the lower quota equals 41. A suitable modified divisor is 21,538.83. Now, step 5. Recompute quotas using this modified divisor. Example, Kent has 162,310 divided by 21,538.83 is equals to 7.535, which is equivalent of 7. Next is Newcastle. Has 538,479 divided by 21,538.83 is equals to 25.0, which is equivalent of 25. Sussex has 197,145 divided by 21,538.83 is equals to 9.153, which is also equivalent of 9. Now add them. 7 plus 25 plus 9 is equals 41. So the standard divisor is 897,934 divided by 41 is equals to 21,900.82. Our modified divisor is 21,538.83. So we have the summary table if we can look further. And now let's move on for the answer. Therefore, the final seat is Kent has 7 seats, Newcastle has 25 seats, and Sussex has 9 seats. And that would be all for the solutions.
Let's proceed to Jefferson's method conclusion. So Jefferson's method is an apportionment system used to distribute seats fairly among the states or groups according to their population. The method works by dividing each population by choosing divisor to obtain a quota. After computing the quotas, the decimal parts are removed and only the whole numbers are kept. If the total number of seats assigned is less than the required number, the divisor is adjusted downward and the calculation is repeated until all seats are distributed. One of the main advantages of the Jefferson's method is its clear and consistent mathematical process. By always rounding down, the method ensures that the numbers of the seats will never exceed the total available. However, this rule can also create a bias because larger states or groups are more likely to benefit when the divisor is adjusted. Even with this limitation, Jefferson's method remains an important concept in the study of apportionment and representation because it shows how mathematics can be used to organize fair seats distribution in government system.
And these sum up our presentation. The following references guided and supported the information we discussed about Jefferson's method and apportionment. We would like to acknowledge these sources for helping us understand the topic more clearly. Thank you very much for your time and for listening to our presentation.